All right, if the triangles are congruent, then we can go ahead and share some of these measurements. So if E to O is 7 centimeters, then in triangle 1, V to U should also be 7. If angle L is 65 degrees, so should angle G be. If angle O is 37, angle V should also be 37. And then to find the missing, we can come out here real quick and subtract 65 and 37 from 180 to get that each of these should be 78 degrees. So definitely not drawn to scale because that kind of looks like it should be a 90-degree angle. But mathematically, that's not how that one would work out. So angle V should be 37 degrees. Angle G, 65. The side from V to U we saw was 7 centimeters. And then the last thing it wants you to do is write a congruency statement. So if it says triangle OEG, then we need to name the second one the same way. So VUL. All right. For this next set, we want to kind of get back into the habit of writing some of these in an informal proof. We are going to do a lot more proof this unit. I know we've kind of taken a break from that since the third unit, but for pretty much everything after today, this entire unit is just total proof based, okay? So it says to explain your solution in each section with an informal proof while also solving the question. So given that the triangles are congruent, find the value of x. Think of this as like part A. All right, if the triangles are congruent, think back to when we wrote our proofs in Unit 3. The first thing you want to start with every time is anything that's given. So my first statement would be the triangles are congruent. And I'm just going to say because that information was given. Now, I'm not really setting this up like a formal statement column, reason column necessarily, but just getting back in the habit of writing out everything you're thinking in your process of solving. So if I know the triangles are actually congruent, because that information is given, then I could say this angle that's represented by 2x minus 16 should be the same size as this angle that's represented by 90. Because if the statement tells me they're the same, then angle, y'all pause, my pencil died. I'll just try to type this out. Then I would say angle ACB should be congruent to angle DCB. And really, I could also just say, because that's also given, right? Based off the congruency statement, I know that those two angles should be the same size. If those two angles are actually the same size, then 2x minus 16 should be the same size as 90 degrees. Okay? So far, these are kind of like the three thoughts we've had. So if that's the case, add my 16, divide by 2. X would be represented by 53. All right. Similarly for your part B. It says find the measure of angle DBC, which is this section right here. All right. Again, if we know the triangles are congruent, I would state that first. They are, in fact, congruent because the problem told me that information. All right. What I can use from the first triangle at the top is that I know if angle A is represented by 49.3, angle D should also be 49.3. But I want to say angle A should be the same as angle D, also because that was just given in the congruency statement. So angle D should also be 49.3. Once I know that, I can just subtract from 180. 180 minus 90 minus 49.3. and I get that the measure of angle DBC would be 40.7 degrees. Okay, so again, this is not a formal proof with, real nice, neat statements and reasons. It does say we can do informal. We're just wanting to get back in the process of writing out everything that you're thinking stepwise, so that when I read through your answer, I can really see what was your thought process to get to 40.7 degrees, not just an answer. Okay? So I'm going to also leave this second one then for you to do, and I would like for you to go back and attempt that. Please do not leave it blank, okay? But look at the same way we just modeled A and B from this first one. Do the same type thing for the second one, okay? All right, and then the last one. This one is kind of a little bit longer, a little bit more formal proof. Given all of this information at the top, so they tell me that angle YWX and YWZ should both be right angles. YW bisects angle XYZ. W is the midpoint of XZ at the bottom, and then XY is the same as YZ. We're trying to show that the two triangles should be the same. All right, because remember at this point, in order to show that two things are congruent, I have to show that all of their sides and all of their angles match. So it makes sense that this proof looks really long, because there are 3 sets of sides and 3 sets of angles. You got a lot of stuff to show is congruent. All right? So take it a step at a time. You can see I've already kind of given you some to start with. So the first statement, I know that YWX and YWZ are right angles because that information was given. And if you'd like to, go ahead and add that into your picture. All right, both of those should be 90-degree angles. All right, if both of those are right angles, then that means that those angles should be congruent to each other, which seems kind of common sense, like we wouldn't necessarily have to state that, but we do want to add that in. If those two angles are right angles, those two angles should be congruent to each other. And my reasoning is that all right angles are congruent. Again, sounds like a pretty common sense statement, but if any two angles are 90 degrees, they should obviously both be the same. Okay? All right. Thirdly, they tell me that YW bisects angle XYZ. That was our second given statement. All right. If we think back to unit 1, 2, and 3. If YW bisects, that means it cuts in half. All right, so on our picture, angle XYZ is this angle up here at the top. If it got split in half, then that means now this section, XYW, and this section, ZYW, should be congruent. All right, so that's going to be my next statement. Remember, everything should kind of flow with your proof. Kind of every step should come directly from the step before it. So I'm thinking, well, if that angle just got bisected, what does that mean? It means now that those two halves are the same. And our reason is because, by definition, that's what a bisector does. It takes an angle and it cuts it into two now smaller and congruent angles. So our reason is definition of a bisector. That's what it means to bisect. We're going to use that a lot, that kind of definition of. All right, the fifth one, W is the midpoint of XZ. That was also given. All right, so same thing as 3 and 4. I think, well, if W is right smack dab in the middle, what does that mean? It means that now this half and this half should be the exact same size. So I want to say that X to W should be the same size as Z to W, because that is what a midpoint does. Definition of a midpoint. All right, number 7. How do I know that XY is the same as YZ. They gave me that information, so I'm just adding that to my picture. All right, so far we only have one set of angles, one set of sides left to talk about. All right, the next one I'm going to mention is kind of a new reason, but let's think about what we have here for a second. If I were to take this triangle apart and essentially copy it into like the two sections you see, do you notice how this side from Y to W should be the same in both triangles? You've literally just taken a side and you've split it, but if I were to push those two triangles back together, that would be the same section right up the middle, okay? So that seems kind of common sense as well, but we have to say YW should be the exact same as itself if I were to pull those two triangles apart. And your reason, anytime, so you might even want to kind of highlight this one to the side. Anytime you talk about how something is the same as itself, so like an angle is the same as itself or a side is the same as itself, your property is called the reflexive property. And I always kind of like to explain that reflexive sounds kind of like reflective, which is, a reflection in a mirror. When you look in the mirror, theoretically, you should look the exact same as you do in real life. So, sounds kind of silly, but that side should be the same as itself. It's been essentially just reflected right here, okay? All right, and now we only have one set of angles left to talk about, and those are the angles kind of left out here on the end. Those angles have to be the same as each other by something we call the third angles theorem. So let me just give an example down here. We know that this angle is 90, so is this one. If I say that this angle up here is 60, for instance, that angle is also 60. If I do 180 minus 90 minus 60, the only number I will get will be 30. It's not possible to subtract the same two numbers on this side and get a number that's not 30. So if I'm given what two of the angles are, that third pair of angles has to be the same. Mathematically, it couldn't work out any other way. So angle X has to be the same as angle Z because of the third angles theorem. And I'm just going to abbreviate theorem like that, THM. Okay? So, now that we have talked about the fact that all sets of sides are the same, all sets of angles are the same, I can finally say that triangle XYZ and triangle ZYW are congruent, and I would say because all corresponding parts are congruent. Okay? I've talked about how every angle matches with its partner, every side matches with its partner, so if all the corresponding parts are the same, the triangles have to be congruent. Okay? All right, homework-wise for day 1, you've got a few kind of just completing the congruency statement. 5 through 7, we didn't really do one like that in your notes, but what you're doing is essentially taking the way that the triangle is the way it's listed as being congruent, and I want you to make marks on your picture indicating that they are congruent. So for instance, if angle G and angle D should be the same, 1 and 1. If H and I should be the same, 2 and 2. Then I in the first triangle would be the same as C in the second, like so. Also, we have to mark the sides. So if G to H gets 1, D to I gets 1. If H to I gets 2, I to C gets 2, G to I gets 3, D to C gets 3. So that your picture is kind of 5 through 7 and then 8 through 10 should kind of be opposite. Given the statement, sketch your picture, versus given the picture, write a congruency statement. Okay? All right, so you've got roughly 12 problems in all. Keep in mind I'm going to check that tomorrow, and then I'm also going to check that we have these notes filled in. So don't forget to go back for like the 2 that I left you here and then also here to make sure you kind of practice a few of those on your own, okay? And if you've got questions, feel free to go to tutoring tomorrow during Tiger Time, okay?